marketing coverage. Filler. This is filler for
I really look forward to you splicing 8 hours of filler.
Good. Which is when you were a kid, did you ever just go out by?
I was born in the year of the before. Oh, I don't know. 83.
Okay, so this
Pig.
is pig.
Oh.
Would you like him to make a pig?
Sure. Oh yeah.
Yeah. So you'll be oil again.
Pull it back out. Yeah. Pull out. I put it in.
Put your teeth on it. Don't bite.
Make a face.
Enjoy it.
Smile. Smile. Yeah.
No, wait
for Tim.
You guys look really calm.
Just
Smile.
doing some warm-up. Getting yourself psyched. You guys.
Let's play the song. Now it's a problem.
You eat it.
What pulverizing is it's essentially a process where the coal comes in, maybe golf ball size, and then leaves as a fine powder, similar to like baby powder or something like that. And that's what's actually combusted. The pulverizers are big machines that just rotate in a cylindrical manner, where it's a vertical gravity feed, and it comes out as a powder. It then goes into the furnace or boiler. Those two terms are synonymous. And in this, it's continuous combustion. It's continuous combustion where once you ignite it, you continue to feed the fuel source in as with a gas turbine, and it stays lit. You don't need a spark any further. But essentially what you do is you have a long, tall, vertical furnace with pipes in it that run hot water essentially and take the water to steam. And Jeff had some questions yesterday about the efficiency of the coal plants here. And you'll hear terms such as subcritical, supercritical, ultra supercritical. What that's referring to is the inlet temperature and pressure when the steam is inletted into the steam turbine. So if you think about the process, you combust pulverized coal to generate a heat source. The heat source then goes through a heat exchanger, which is the boiler or furnace, to heat up water. Water then goes to very high temperature and pressure, possibly around, I don't want to get these numbers wrong, but for a supercritical plant, maybe 3,000 degrees F and 1,500 PSI, very, very high temperature and pressure. And then it goes to the steam turbine. One of the things that will be very interesting to look at is the intricacy of all the pipe work in the pulverized coal plant. And the steam turbine is really the main working of a coal plant. And if you think about it, all that a steam turbine is a series of fan blades that get hit with really high pressure steam. So think a squirt gun against a fan blade that makes it rotate. And you actually have something called a nozzle that directs the flow of the steam path between stages of the rotor, which create the most efficient utilization of the high temperature pressure resource. You then expand the high pressure temperature steam throughout different sections of the turbine. From an efficiency perspective, it's actually most efficient to have multiple sections of a steam turbine, and the steam path is the path that the steam flows through, and you're essentially just expanding the steam through that to convert the high temperature pressure steam to rotational mechanical energy. This steam turbine may or may not have a reheat cycle, and you may hear them say it today, all steam cycles are Rankine cycle, and you can calculate the efficiency of it based upon looking at the inlet temperature and pressure and the exhaust temperature and pressure. Once the steam leaves the low pressure section of the steam turbine, it then goes through a condenser. Because of the fact that you need to condense the steam back to water to push it through the process, you then use pumps to continue to push it through the process. Putting a condenser on the back end also creates a vacuum coming out of the low pressure section, which increases the efficiency of the cycle. I would assume that the efficiency of the cycle is probably in the 35% range. So that's the steam loop. When you see the big cooling towers, what you're seeing is water that is being used as a heat exchanger to cool and condense the steam back into water. So the water that's coming in plumes out of the big cooling tower, that water is not part of the closed loop cycle. Real quickly on the emissions out of the furnace. So in combustion, there are many different byproducts, some which you can manage and some which you cannot. Sulfur dioxide is a very big emissions concern from pulverized coal plants. In the early 90s in California, they actually started a cap and trade program to decrease sulfur dioxide emissions, and you can put scrubbers on the back end. Particulate matter is what causes the haze that we're seeing here. You heard him say yesterday PM 2.5. As Lauren was discussing, 2.5 is the size of the particulate matter, meaning smaller than 2.5 microns, and those are somewhat difficult to capture, but you can capture them with post-combustion processing. A quick comment on carbon dioxide. In combustion of hydrocarbons, complete combustion yields CO2 and water if you go back to your chemistry. And there is no way to reduce the carbon dioxide in combustion other than removing it from the post-combustion stream or removing it pre-combustion through a gasification process. You commonly hear people refer to clean coal. What clean coal usually refers to is IGCC. This plant is not IGCC. IGCC is integrated gasification combined cycle, where you take the coal and convert its state from a solid coal resource to a syngas, which is carbon monoxide and hydrogen, and you can remove the carbon content prior to combustion and then combust the syngas in a gas turbine and drive a combined cycle. I think that's a lot of details right there. Thank you.
All right.
他马上下来。
也有很多危险，大家一定要注意安全。
Yeah, so again, like safety, you should like make sure we are working together.
Important. Yeah, we transport the coal by the train, and sometimes they transport, army things here by the train. So yeah, we have a plant here, and it's very old. This power plant was constructed in 1958. 4,000 or 5,000 tons a day per day. Yeah. Okay.
Can you talk a little more about the emission control equipment to reduce pollution? And did you have to have more because it's in a city?
Yeah. Our desulfurization system is from Germany. Yes, was maybe one of the first desulfurization system in China.
The oil companies set up one of these in Houston too.
Oh my god, they're going inside.
Thanks, man.
They're out again.
我们的排放指标全球65个国家都是可北京制造者，是国内第一家对我们国家环境友好企业开放的电力企业。
Thank you so much.
Very handsome.
The cool thing about it is that it's far enough out that where the turbines would be built, 8, 10, 12 miles. Essentially, you can see
I'm not willing to take any risks, guys, please. Oh yeah. So this is a turbine generator right here. What? Right here. This is a turbine generator.
Yeah, so yeah, the two units of 200 megawatts of boilers together it's 400 megawatts.
下面明显是的，第一在变出 point 而且这就是100元的那个量嘛，我在 Internet。100元。
For construction of flow, that kind of thing. Yeah.
But it's just
We'd like to thank you very much for giving us the tour. This is from the Stanford University.
Okay.